Dear guests, dear colleagues, a very warm welcome on behalf of the Austrian Center for Digital Humanities and Cultural Heritage. Before getting down to brass tacks, I'd like to say a few words about what kind of event you're attending here and about our esteemed guest. I should like to draw your attention in particular to the fact that there is a number in front of this lecture. It's 9.1, if you have checked it out on our website. And this number 9 has a significance, indicating that we are in the 9th year of our lecture series, which started on the 9th of April with a presentation given then by Jan Ondijk on Claria, a research infrastructure for the humanities in the Netherlands, 9 years ago. 9 years and 25 lectures on, we now have the pleasure and honor to welcome today a guest from Germany, Professor Dr. Achim Rabus. Our guest is a Paleoslavist and holds the chair of Slavic linguistics at the University of Freiburg. Before that, he served as professor at the University of Vienna and the Alexander Brückner Center for Polish Studies at the Universities of Halle and Jena. Having studied Slavistics, musicology, and business studies at the universities of Freiburg, Basel, and Kazan, he wrote a doctoral thesis on the language of East Slavic spiritual songs, which was followed by a habilitation about Slavic language contact in 2014. Since 2009, Professor Rabus has been a member of the Special Commission on the computer-supported processing of medieval Slavonic manuscripts and early printed books to the International Committee of Slavists. Since 2018 also as the president of this commission. From 2011 until 2016, he was a member of the Junior Academy program of the Heidelberg Academy of Sciences and Humanities. In 2012, he was awarded a Fyodor Linen Fellowship to conduct research at the University of California in Berkeley, sponsored by the Alexander von Humboldt Foundation. Rabus has authored 2 books and uncountable articles, and been the principal investigator of several philological, sociolinguistic, and digital humanities projects. He has been pursuing research in Slavic sociolinguistics and dialectology on the one hand. However, large parts of his research have a strong methodological component, which has made him a well-known advocate of digital humanities, focusing on new approaches in historical linguistics, corpus linguistics, the creation of linguistic data in form of part-of-speech annotations, and full morphology tagging of medieval Slavic texts. Most of our guests here will know that this lecture series goes hand in hand with a series of more practical events which we call tool galleries. And in the light of what we will hear today, it appears worthwhile mentioning that the first ever tool gallery, also in 2015, was on the topic of automated recognition and transcription of handwritten documents. And here we come to full circle, as the topic of today's presentation is titled Exploring the Boundaries, the Present and Future of AI-Powered Handwritten Text Recognition. What of course strongly moves the minds these days is the AI aspects of it all. I suppose we hear of Transcribus again and learn what it has got to do with ChatGPT. For the audience, this session is being recorded, and we will have the opportunity to ask questions afterwards, which will be moderated by our colleague Robert Klugseder, after which we have some fortification for you downstairs in the Alte Börse. The floor is all yours.
Thank you very much for this kind introduction. Thank you very much for the invitation. We are going to talk about handwritten text recognition today. And we will start, of course, with a short introduction to HTR, or handwritten text recognition, and I will present my vision of humanities research in the digital age. Let's dive right in, shall we? All right, so HTR is relatively, well, let's say new technology as opposed to the more traditional OCR, optical character recognition, which you all know for printed text. And these handwritten text recognition approaches, they are based on artificial intelligence and more specifically on so-called neural networks, which is a technology that has gained traction in the last couple of years. The special feature is that HTR technologies, they take into account not only the individual letters or glyphs, but also their direct environment, which means the neighboring characters or glyphs or whole words or even whole lines. Essentially, this technology is line-based. And this means that recognition quality gets incomparably better using this AI-powered approach. Because if you see an individual letter, say C or E in the Latin script in the wild without a context, it might be difficult to distinguish between C and E. But if you know the context, as you do as a philologist or as an AI, you might be able to understand it considerably better. And that's what has happened in the HTR domain. And this means that nowadays, for the first time in history, it is possible to conduct handwritten text recognition in a variety of languages and scripts and script styles, and with a comparably low error rate. And with respect to old printings, the recognition quality has also greatly improved. You get 99+% correct text with good old printings. It's of course worse with handwriting, but we will see the figures later on. And as most of you already know, we have a tool from Austria, Transcribus, which is arguably not the only, but in my opinion, the most advanced and feature-rich platform for handwritten text recognition today. Can I see your hands? Who has experience with Transcribus? Who has worked with Transcribus? All right, so that's maybe 50% here in the audience. Thank you very much, that's good. Transcribus has been developed in Innsbruck, and they have more than 100,000 registered users, which is a great success story for a digital humanities project, of course. You can go to this internet website and download the expert client. You can also use the browser-based client, which will be the future of the development of Transcribus, and use Transcribus in the browser. You can just play around here and just upload a random image of a manuscript and see what happens. It's interesting to see what happened. We all know that sustainability in digital humanities projects is usually an issue. You have third-party funding, and then you run out of funding, and no one knows what will happen, right? So we have things like Claudia, of course, who take care of that. But the Transcribus people, they chose another path, and they founded a so-called European cooperative, which means this is not a company to make money, but this is a consortium or something like that of with different actors. You can become a member of the co-op, and you can take part in deciding where to go next. But this also means that Transcribus is not open source, and it is not free. Right, you can transcribe 500 pages for free, but if you do mass digitization, you have to obtain credits and use them for each individual page you would like to have transcribed. If you would like to learn how to use Transcribus, there are very nice and very detailed tutorials around, and I recommend if you're new to that, try them out because they're really very helpful. So let's talk about my vision. My vision, this is a multilingual full-text searchable archives. This means imagine a world where you have full-text access to all manuscript available, no matter what language, what script, or what time period. And Transcribus or similar tools might be the tools to help us get there. And I'm going to show you what I have in mind here. This is the so-called read and search environment. As a matter of fact, they invented a new name for it, but I can't remember it right now. It used to be called read and search environment. And here we go. This is a page of the Amsterdam City Archives. And as a back end, you have the Transcribus HTR. And this is just a browser-based front end. And you can go here and search for Vienna. And then you see all the manuscript where Vienna is written. And this has been all transcribed using HTR models within Transcribus. And imagine you had that for all archives and for every manuscript. That would be just, well, nothing short of paradise for historical philologists, right? Okay, so this is our vision, and HTR and Transcribus will help us get there. To be fair, Transcribus is not the only tool available. There is competition, and we have written a paper where we compare Transcribus, the performance of Transcribus, with other tools that are available, among others, open source tools. And in my opinion, the most advanced competitor from the open source camp is Kraken or eScriptorium. Kraken is the HTR engine, and eScriptorium is the platform, the front end. The performance, when it comes to error rate, is quite similar to Transcribus, with the exception that they do not have a language model implemented yet. We will talk about that later. However, the main advantage, of course, is that it's open source and it's free. The disadvantage is that training is somewhat non-trivial. First, you need to have appropriate hardware to do it. Second, you need to be able to use the command line in an advanced way. And of course, you have the cost of opportunity to maintain a server and to buy graphic cards for training and things like that. But nevertheless, this is an interesting and viable open source alternative, in my opinion. There are other tools around, such as Calamari, OCRD, OCR for All, and also a product from the Czech Republic, Pero OCR, which is also available, and the quality, recognition quality is also quite satisfying. And of course, there's big tech, commercial companies, also small or middle-sized companies, as well as startups in this domain. Let's have a look at a couple of screenshots. This is the so-called expert client, Transcribus expert client. We have the more modern browser-based client here. It's more or less the same manuscript, but just the other front end. This is eScriptorium. Also looks more or less the same. We have OCR for All and Pero OCR. So the principle is the same, but the things that go on under the hood are somewhat different. All right, let's continue with the so-called HTR models. What are HTR models? That's where the AI is hidden, right? You need to have an appropriate HTR model that fits your data. That means the language you're interested to transcribe, the script with the similar paleographic characteristics. And if you don't have a model yet, you need to train them. You need to train a model. And in order to do that, that's an instance of so-called supervised learning. From an AI perspective, you need to have so-called ground truth. Ground truth means you need high-quality images of your sources and line-by-line corresponding transcriptions. And if you have that, you can start training models. But if you use Transcribus or Scriptorium also to a lesser extent, you can benefit from the fact that people have already trained models, and these models are publicly available. So if you're interested in, say, German cursive or late medieval German book scripts or something like that, you will find models that are ready to use within Transcribus. So you do not need to train from the scratch, but you can start with already existing models. That's the difference between so-called public and private models. There are many public models for Transcribus available, some public models for Kraken Scriptorium, but of course there are numerous private models we all don't know about because they are just private within the individual working groups. The amount of training data is crucial. You cannot start with 2 pages of transcriptions. You need at least, as a rule of thumb, you need at least, say, 5,000 words. Well, with respect to this particular source, but the performance will be worse when trying to transcribe another kind of source. In order to transcribe a wide variety of sources, you need so-called generic models that have been trained with a variety of different sources, with different paleographic characteristics, maybe even different linguistic features. And then you need more training data. 100,000 words is not uncommon. There are models with more than a million word tokens. And they are quite versatile. They can be used with different kinds of sources. And that's how a training curve looks like on the right here on the screen. Within Transcribus, you can use different so-called engines to train models. The go-to engine is so-called Pylaya. And there are also transformer models. And transformer is the more advanced technology that is also the basis of ChatGPT and other large language models. And as of now, it's impossible to train your own transformer models, but in the future you will be able to fine-tune a transformer-based model. But if you start with Transcribus, you will most likely use Pylaya and train your own models. We can see an example of a specialized model here. This is Parzival, that is Middle High German, very clear handwriting, of course. And we have a small to medium-sized model, 25,000 tokens, which is okay, but it's not that much. And we have a very low character error rate of below 1%. CR stands for character error rate. And the lower the CR, the better your model, of course. And if you're a specialist in Middle High German, you see there are almost no errors in this transcription. But of course, you do not need to be a trained medievalist to read that text because it's very legible. What about using Transcribus or other HTR tools for more complex scripts? For instance, you see an example of modern German handwriting, and the special feature of this handwriting is that this is a diary of a woman, and she learned how to write in the area of Sütterlin. But afterwards, when she was an adult, she switched to the Latin alphabet, and we can see it here. It's quite hard to read, even, well, for humans. And we see, of course, that there are errors, but still, without additional training, it would be hard for humans to reach that kind of performance, I guess. So that's quite a large model, and we are grateful to the Deutsche Tagebucharchiv Emmendingen for the fruitful collaboration in this respect. These are models that transcribe complex handwriting, but they're also so-called smart models. What do we mean by smart models? These models are capable of doing something more beyond pure transcription. For instance, they are able to learn how to separate words. In medieval text, we usually have scriptura continua, that is, there are no white spaces between the individual words. And you need to be a trained philologist to know where to put the white spaces. We can also train models to do some of the editorial work, to add hyphens or parentheses or other features usually human editors do. You can train models to resolve abbreviations. You can have one source and different models, for instance, a normalizing model or a philologically faithful model. That's also possible. You can transliterate into another alphabet. And you can also reverse the directionality. If you transcribe a script written from right to left, like such as, for instance, the Hebrew alphabet or the Arabic alphabet, you can have a transliteration in Latin script going from left to right. That's also possible. And I will give you a couple of examples of these smart models. Let's start with pre-modern Slavic. And there are a couple of people in the auditorium who are able to read that, but that's not extremely important here. What you can see is we have scriptura continua, so no white spaces, but the model learned to add these spaces in the transcription. And also the hyphens. That's a word that continues in the next line, and the model has correctly, well, in this case, incorrectly, but usually the model does it correctly. And this is a public model that anyone interested can use. It's available via the Transcribus platform, and it has these smart features. You can also train models to modernize orthography. This is early 20th century Russian, and Russian orthography was modernized in 1918. And some letters, they got rid of some letters. And you can train the model to do that for you. As you can see here, this is, well, early 20th century Russian handwriting, and we have a letter that is no longer in use, the so-called yat, and it has been automatically converted to the contemporary air, right? That's what you can do. And you can also You can also, I have talked about it, train models for different purposes. This is a chronicle, an Old East Slavic chronicle, and we see the month of October on the 18th day, and these are two different models. We see here, this is the philologically faithful model. We have superscripts, we have abbreviation, we have, well, faithful punctuation, also here abbreviation. We have the Slavic way of writing numbers with letters. Here also an abbreviation. And then we can train another model that is more, let's say, for a broader audience, that resolves the abbreviations here, and converts the numbers to the Arabic numbers. So both is possible. And if you have models with these smart capabilities, usually the CER, the character error rate goes up, but it's still quite usable. All right, let's move on. Here is Glagolitic. Glagolitic is a script originally for Old Church Slavonic, but in the late Middle Ages until the early modern times used in Croatia. And this is the so-called Angular Glagolitic script. And the model for Angular Glagolitic script, which is also publicly available, is capable of transcribing from Glagolitic to the Latin alphabet, and also of resolving abbreviations. As you can see here, that's a very common word in a spiritual text from this period. And everything which is written in these parentheses has been automatically added, and in this case correctly added by the smart model. And this also works with many letters. Here, this is a very frequent word, blessed, and everything between these parentheses has been added by the model and correctly added in this case, which is the first time I saw this, I was pretty impressed, because this is really smart, isn't it? Okay, let's move on to the directionality issue. This is Yiddish. And Yiddish is written in the Hebrew alphabet and is written from right to left. But you can train a model that transcribes to the Latin alphabet, and Latin reads from left to right, as we all know. And this means that you can gain access to sources you usually don't have any access to, because you're not a trained specialist in Yiddish studies or in Jewish studies. But if you are a speaker of German or Germanic varieties, you will most likely be able to understand a bit. So transcribers contributes to the democratization of knowledge in this case. And this is also the case when looking at our next example, which is the most sophisticated so far. This is German shorthand, so-called Deutsche Einheitskurzschrift, German shorthand. Full disclaimer, I cannot read that, but we trained models for that. And of course, there are many errors, but you can understand it. Look at that. This is quite readable, and you can infer, you can correct the errors in your minds, right? So this is also a case where HTR contributes to the democratization of knowledge. Which brings us to our next chapter, and that's large language models and HTR. We all have played around with ChatGPT and other tools and it's really impressive what they can do, and sometimes it's really funny what they are unable to do and which errors they commit. But still, it's the crucial. We're in a crucial time, in my opinion, to see what happens next with these large language models, both in academia and outside of academia. And with respect to handwritten text recognition, I also played around with this tool, and I used the successor of ChatGPT, which is GPT-4, and asked GPT-4 to correct the HTR result of the shorthand example. So first, Transcribus, shorthand model, HTR result with errors. Second, GPT-4, please normalize this text and make well-formed sentences. And if we have a look, it's not visible very well, but maybe you get the point. Above is the original HTR text, and below is the GPT-4 corrected text. And in most cases, it corrected the text correctly, right? Sometimes it introduced additional errors, but in this example, just in one case. So if you use, if your HTR result is written in a modern standard language, you know that GPT-4 or ChatGPT, they perform best in English, and the other large Western languages are a bit worse, but still pretty good. And you can see with the standard German, it's not a huge problem for GPT-4 to get decent results. And this means you can establish a pipeline where you start with HTR in Transcribus and afterwards have GPT-4 correct your results. But you can also use LLMs such as GPT-4 for document understanding or named entity recognition. And you can establish a, well, you can continue in two steps. First, ask ChatGPT or GPT-4 to correct the errors of HTR, as we've seen before, and maybe modernize the orthography. And second, write an XML file. And we know that in digital humanities, we are very fond of structured data, and you can have GPT-4 write this kind of data for you. This is just the first try of an XML file produced out of the HTR result. This is a Russian language text from the 19th century, and we see we have names, we have cities, we also have religion and occupation. Below there, one of the persons involved apparently was in the military, and we see also the rank and the subunit, and this is rather correct. Of course, there are still numerous errors, but it's fascinating, in my opinion, what large language models are capable in this respect. Okay, so the last example with the GPT-4 is the idea of summarizing. We are training models for Ottoman Turkish. I am not able to read and understand Ottoman Turkish. We have somebody in our team who's able to do that, but I can't, honestly. And for this example, I just took an HTR result of Ottoman Turkish, and to be honest, the CER, the character error rate of this example is quite high. It's above 10%. And usually, as a rule of thumb, you say you need to be lower, you need to be better than 10% to get usable results. But Ottoman Turkish is hard. It's complicated to train because of the vowels or missing vowel signs, and you get this result. And you have many diacritics and all this stuff, but I just copied this part to GPT-4, and here is the result. So it recognized that it has been written in Ottoman Turkish and in the original Arabic script, even though the prompt, the input was in a Latin transliteration, right? And I've double-checked with the competent colleague, and that's more or less what they are talking about in this text. So you can use it even if you don't have a clue, even if you don't have an idea, you can use it for document understanding or for distant reading in the widest sense of the word. This means LLMs are another game changer. HTR is the first game changer, and LLMs are a second game changer, because if you deal with modern standard languages or with languages where there's a lot of training data in LLMs, you do not need to have an extremely low CER to get decent results, to use your text for further analysis, because you can use LLMs like GPT-4 for post-processing. And this is great news, but there are use cases where you cannot do anything with GPT-4. For instance, with Church Slavonic, and if you're a philologist in Slavic studies, you need to work with Church Slavonic, and you cannot use GPT-4 for normalization. It will inevitably get Russianized or something like that, and you don't want that for your philological analysis. This means there's still need for training good, high-quality, low CER HTR models for historical, for pre-modern languages and historical scripts. But for some tasks in the digital humanities, it might not be necessary to have a low CER at all, because if you do document understanding, ChatGPT or GPT-4 will be able to do that, even with a higher CER and many errors. Okay, let's go to our next chapter, using uncorrected HTR data for quantitative analysis. And I would like to talk about an interesting issue, in my opinion. What to do if you're a trained philologist. 0.5% error rate is way too high. You strive to get 0, right? And that's an approach that you will most likely never get, most likely, with the most manuscripts, a 0% error rate with HTR. But the main advantage of this technology is that you can conduct mass digitization. It's possible to digitize thousands and even millions of handwritten pages for a low amount of money in a short amount of time, right? And this means that we need to think about how to adapt our methodology. Is it possible that we, as philologists in the digital age, get comfortable with the incompleteness and margin of error? And I think, yes, we need to do that. We need to accept that it might be a viable alternative to analyze thousands of pages with some noise, with some errors, and the results are maybe more meaningful as opposed to analyzing merely a couple of hundred of pages with no errors. And that's, maybe we can discuss this in the discussion later on. Maybe this quantitative paradigm, big data with noise, is an alternative to the philological paradigm. We have a couple of projects with pre-modern Slavic or Church Slavonic, where we trained a pretty large corpus of 16th century Church Slavonic, 25 million word tokens, which is for a historical corpus, it's pretty decent, in my opinion. And we tried different approaches, how to deal with this uncorrected data and how to use it for quantitative analysis. And the first step was trying out part of speech and full morphology tagging. Has been said before, but we've been working in this domain for a couple of years. And part of speech and full morphology tagging for pre-modern Slavic is non-trivial because the tag set is really large. You have rich morphology in the rich noun morphology and also rich verbal morphology, which means the tag set is really large, and you have variation in orthography and things like that. And we trained an AI tagger with an accuracy of more than 90%, which is pretty decent for a complex setting such as pre-modern Slavic. And we have shown that it's possible to use Church Slavonic raw text and tag it and don't correct the tagging and still use it for quantitative analysis. But what we haven't done yet is combine two noisy methods, and that's what we are going to do in our ongoing project. At the first step, we use an uncorrected transcribus transcription with a noise introduced by the HTR algorithm. And second, we post tag or full morphology tag this already noisy text. And then we will have a look what happens if the noise will grows in a linear or in an exponential way. This is how tagging looks like. You do not need to understand that completely. We have the tokenized tokens in the left column. Then we have the lemma here. Then we have part of speech, and then the full morphology. This is more or less typical. If you're a corpus linguist, you know what I'm talking about. And then we applied we tagged our transcribus text and had a look at the results. And the first results do not look that bad because we just selected this is also, obviously, this is a religious text, and we selected the most frequent noun lemmas, as can be seen here. And we have God, we have day, we have soul, we have word, we have the Lord, Father, man, body. And this makes sense. This means that first noise transcribus, second noise tagging, but still it looks pretty good. But of course, we try to do that in a more systematic way. And we made an experiment where we had a look at a text that is available both manually corrected and as a transcribus HTR hypothesis. And then we searched for a phenomenon that could be a linguistic feature that could be analyzed both with a traditional surface search, that is, just look at the ending, for instance, and with searching for tags. And doing that, we got 4 different subcorpora: manually corrected transcription, manual search, transcribus HTR, manual search, post tag search with the manually corrected text, and post tag search with the transcribus. Right? That's what we did, or what we're in the process of doing right now. And this is the first slide devoted to this topic, where we compared the HTR tag and the manual tag. And we see that with the most frequent parts of speech, there's not that large of a difference. The most significant difference is with the tag punctuation. And this means that Transcribus apparently omits full stops or other punctuation marks. And we need to address this issue in pre-processing. But with respect to the other parts of speech, it looks pretty similar. The same holds with full morphology, tagging. And here we see the 4 different subcorpora I talked about a minute ago. And we were looking at a specific Church-Slavonic morphological feature. And this is the baseline, this is the gold standard, where we had the manually corrected edition and the manual search, and we have 725 instances of this particular phenomenon, and these are the other subcorpora: noise with Transcribus, noise with tagging, and double noise, right? And as you can see, it seems to be the case that the text in question has been written by 3 different scribes. And these scribes had different ways, different orthographic principles, right? So with respect to a particular feature, some wrote it in a contracted way and some wrote it in the regular way, if you will. And you can see this variable here. We have the manually corrected, manually searched corpus here. This is scribe number 1, scribe 2, scribe 3. This is tagged. This is a Transcribus and manual, and this is double noise. But as you can see, the differences are insignificant. The bars look more or less the same. The tendencies that scribe number 3 strongly prefers one variant is clearly visible, even with the double noise here, which is really interesting, which means you can use both Transcribus and tagging in a pipeline without corrections. It works. It's possible to add the noise without getting complete garbage. But of course, some ways of analyzing the data might not be feasible if you have too much noise. You have to stick to the old principle, know your data. If you don't know your data, you might be lost. And of course, if you work with data that is not pre-modern Slavic, but say early modern German, you can think about reducing the noise by adding an intermediary step with large language models, such as GPT-4. Okay, I'm going to conclude now. Where are the boundaries? In my opinion, the sky is the limit. We've come a long way with HTR. We have different tools, Transcribus, above all Transcribus, but also other tools, open source tools. We have many high-quality models in the scientific community with a low error rate. You can start, if you have typical data, you can start right now with transcribing without having to train your own model. Out of the box, it works. We have models also with smart features, and we are starting to create full text archives, completely searchable archives, which is a great thing. We also, I've talked about large language models such as ChatGPT, and in my opinion, these are extremely promising tools for both post-processing and analysis. And we have also seen that a certain amount of noise in HTRized and tag data does not render meaningful quantitative analysis impossible. And I would like to end with an appeal. We are living in the future is here, let's embrace it together. Thank you very much.